Okay, so now I'm going to continue on talking about motor banks. We'll kind of review some of the single motor the single motor calculations that we went through on the earlier video, just because we'll have to figure out their single motor values in order to find out the feeder overcurrent and feeder conductor size. So it's a nice kind of review of what we did already. I'm going to go a little bit faster through these, but again, slow the video down if you need and make sure that you can follow how to get all this information. So we have 5 motors here. They're different. So this one, things we want to key on. They've given us all in horsepower, so I'm going to have to go to table 44 to get the they're all 3-phase, 480 volt, so I'm going to have to get the FLA from table 44. This one I'd key on the fact it's a transformer start. This one obviously is a wound rotor, so that changes our overcurrents. Okay, so first off, we got to get all of the FLAs from table, except for this one was given to us, from table 44. Then we'll start with this first motor. We take, again, it's just a continuous motor, so we would take that FLA times by 125%, then go to table 2 to size our conductor. So we get 2 watt, 175 amps. Then we're going to take and look at the service factor. We're above the 1.15, so it's 125% of the FLA, so that's why these numbers are the same. So that's what we'd set our overloads at. Then our overcurrent device, we're going to go to table 29, but again, it's a transformer start here, so even though it's a fuse and non-time delay, we're going to go to table 29 and see that it's 200% of the FLA. So then we go find that calculated value from table 29, go to table 13, and we go down to a 225 amp fuse. Okay, and the next one, again, continuous, so we take our 34 times 125%, go to table 2, get our wire size. Again, we're not 125% here because of the service factor 1.1, so it's 115% times 34 amps, so we get 39.1. And the thing to watch out for here is that this is a breaker, so that's why we're using 2.5 or 250%. And then again, we go to table 13 and go down. Next one, again, 125% to find our conductor because it's a continuous motor. Find our overload protection, service factor 1.15, so we're using 125%. Again, that's why these numbers are the same. And then we size our non-time delay fuse at 300%, and we go to table 13 and go down. Next one, again, 125%, size our conductor. 125% because of our service factor, so that's what our overloads are set at. Go to table 29, it's a circuit breaker, so we're at 250% here. Go to table 13 and go down to select our breaker. Now this last one, again, even though it's a wound rotor, we don't have to worry about this secondary calculation because we're kind of just deciding the overcurrent and the conductor going up because we want to size the feeder and overcurrent and conductor. So it's not really important to size the secondary conductors for this question. So we get our 125%. It's a continuous motor. We get number 4s that are good for 85. We size our overloads at 115% because of service factor of 1.1. And we go to table 29, and again we have to watch out, go under the wound rotor for a fuse, and it's 150% times our FLA there, and then we go down to find our fuse at table 13. So we take now that we have all of these filled out, we have all of our overcurrents and our wire size and overloads all sized for all the motors. Now what we have to do is we're going to look at this feeder overcurrent. So because this is a fuse, we have to make sure that all of these are treated like a fuse. So even though they're not, they're a breaker here and they're a breaker here, we still have to find out what the value is as if they were a fuse. Because if we're going to compare, which is what we're going to do, we have to figure out what the largest calculated value is from table 29. So we have to compare them all as a fuse because that's what the overcurrent, the feeder overcurrent is going to be. So we have to find out what this guy would be as a fuse. So instead of a breaker, we used a 300%, and we find out what the calculated value and what his value would be at as a from table 13. And then we do the same here. So we take the 2.5 that we use for circuit breaker, we turn that to 3 because we're treating it as a fuse. So here's our calculated value here and the table 13 value. Because when we go and size the feeder overcurrent, if we go to 28204, it's going to tell us what we need to do. So 28204 says feeder overcurrent protection. So subrule 1 says, for a feeder supplying motor branch circuits only, the ratings or settings of the feeder overcurrent device shall not exceed the calculated value of the overcurrent device, so that's from table 29, for the motor that is permitted the highest rated overcurrent device of any motor supplied by the feeder, plus the sum of the full load current ratings of all the other motors that will be in operation at the same time. So if we go back here, I want to find the largest calculated value. So here's 248, 85, 231, 130, 97.5. So 248 would be my largest calculated value. So I list them all here. I looked at my largest calculated value and then add the FLAs of all the other ones. Okay, so only take the largest calculated, then the FLAs. We add those up. Again, it says the rating of the feeder overcurrent device shall not exceed this calculated value. So I go down when I go to table 13 and select a 450 amp fuse. Now for the conductor, we go to 28108, and it's under insulated conductors for 2 or more motors. So it says insulated conductors supplying a group of 2 or more motors shall have an ampacity not less than A, 125% of the full load current rating of the motor having the largest full load current rating, plus the full load current ratings of all the other motors in the group where all the motors in the group are used for continuous duty. Okay, so that's definitely where we're at here. They're all continuous. So the motor with the largest FLA is the 124 amp motor. So we can see all the FLAs here. Take 125% of that and then add the FLAs of all the other motors. So then we get the 383. We go to table 2 and we select a 600 kc mil for the feeder. So if we go back, we're going to have 450 amp fuse and we're going to have 600 kc mil wire feeding these 5 motors. Okay, so here's another example. These are all non-continuous though, so we're going to use table 27's percentages for this. Okay, and again, I'll kind of go through this a little quick, but you can stop this and slow it down as much as you like to check and verify the values. So we've been given horsepower again, so we're going to go to table 44, find out what our FLAs are based on the horsepower and the fact that they're 208 volt 3-phase motors. We're going to go to table 27 to get our percentages based on short time duty, 15-minute rating, periodic duty 5-minute, short time duty 5-minute, periodic 30. Okay, we're going to use those values to get this calculated current and then size our wire. And we're still going to use the service factor, and the FLA to determine the overcurrent. So the biggest difference is here we're going to table 27. So if we want to just look at this first one just to kind of not go too fast, I guess, through this. If we go to table 27, we're going to be looking for short time duty 15-minute rating. So we go short time duty 15-minute rating. I see it's 120. So if I take that FLA of 30.8 times 1.2, that's where I'm getting the 36.96 from. Excuse me. And then we're going to go to table 2 to size that. And we go to table 29, and we're using 300% non-time delay fuse, going down from table 13, picking a 90 amp fuse. So again, just make sure you go to table 27, periodic duty 5-minute rating. We're at 85%, so that's where we're getting this number from. Again, we're even going lower. than the actual FLA in this case, but that's just because of the duty rating. It's only on for 5 minutes, and when it is, it's periodic. Okay, so we're allowed to kind of downsize some of our ampacities because of that. Still take the service factor, times that by 125% to get our overload. Again, watching this as a breaker, so use 2.5 or 250%, and then go to table 13 and go down to a 40 amp breaker. Same kind of deal here. Again, I'll just kind of breeze through here so we don't take too long. And this last guy again too. So just so if you want to double check when you're going through it, all these ampacities before we pick the wire size are based on timesing the FLAs from table 44 times the percentages found in table 27 because we are non-continuous. Okay. So once we have all these, again, now we got to look at the top of this overcurrent. So we have a breaker coming here. So 2 of these are breakers already. But if this main is a breaker, we need to get all of these sized as if they were breakers in order to compare. Again, if we want to compare all these, which is again what we're going to do, we have to have a benchmark. So they all have to be the same type of overcurrent so that we can compare them properly. Okay, so again, now we go to the feeder overcurrent device, so 28204 sub rule 1, and we go through and find our calculated values from table 29, again, as a circuit breaker, and we pick 77, again, could be this one or this one, they're the same value, and then the FLAs of all the others. We add them together. Again, we can't exceed that value, so when we go to table 13, we'll go down and select a 150 amp breaker. Now, when we do in our feeder our feeder conductor size, we're going to a different rule than we did the first time because these are non-continuous motors. So the first one we went to in the previous example, we went to 1A because they were continuous. 1B says the total of the calculated currents determined in accordance with Rule 28.1062, and 28.1062 is how we decided our conductors for our non-continuous duty motors by going to table 27. For each motor where all the motor groups are for use on non-continuous duty. So again, it says the total of the calculated currents determined in accordance with Rule 28.1062. So basically they want the total of the calculated currents from all those calculated values from table 27. So when we look at all those numbers from the example on the previous page, these are all the calculated values we got before we decided the wire for each motor. Okay, so we take the total of all of these and we go to table 2 and we find that we can use the number 1 that's good for 130 amps. Okay, again, a little bit different because these are non-continuous duty motors. Okay, so it's a different rule. We're actually into 1B here. 1C says if we have a combination of continuous and non-continuous, what we need to do. And basically it's a combination of the 2 rules where we take the calculated values for the non-continuous and we take the largest continuous and the FLAs of all the other continuous. Okay, so we'll read through that rule. If it does, I'm sure we'll have some questions that'll get you into that rule too. So when we come back to this, again, these are all those calculated values I was talking about. If we go back here, all these calculated values are these values right here. Again, not the FLAs, the calculated values from table 27. So we have number 1s that we can pull for this feeder, and we have a 150 amp breaker to supply these 5 motors. Okay, so that's the kind of the long and short of motors and motor banks. The Blackboard will get you into all kinds of questions within those rules, so if you have other questions, make sure you read through the module, do the module exercises. They'll get you into some other examples as well, but obviously ask me questions as you need and I'll help you get through it.